Okay, students. So time to start. Last time I made announcement. We have 7, if I remember correctly, problem from chapter 2, homework problems. Do you remember you have the problem in your syllabus? So today 7 students have chance to take extra credit if you explain one problem. Who wants to explain any problem from homework? I don't push you. If anybody wants, I invite you to go to Blackboard. Explain. If not, don't worry. It was a special for extra credit. Who wants to take extra credit to your final grade? Okay, nobody will. So let me try to do this. Let we go to quizzes. What you have in bright space. Go to. I hope you have with you your laptops. If you don't have laptops, you'll be not very useful, but you can use your smartphones. Smartphones, so and in bright space, now you can find 5 quizzes. 5 quizzes. So quiz 1, quiz 2, quiz 3, quiz 4, and quiz 5. So now we will discuss. No, you have to start to do this quiz. We start last time, if I remember correctly, quiz 1. We start, you have to finish at home here. I will check your results and we will discuss together why we have this result or another. But now you can start quiz 2, start quiz 2. Yeah, to finish quiz 1. Don't start from quiz 1.
You can only take it one time.
What? Quiz 2?
It doesn't have like the unlimited.
I will check now. I will try change.
I think we did quiz 2 last time, and that was all. We did quiz 2 last time.
Quiz 2?
Yeah, we did quiz 1 together, and quiz 2 we did last time.
Okay. If you go to next quiz. Quiz 1, quiz 2, quiz 3, what we have all quizzes, step by step. So now attempt. What attempt? I did not attempt. Okay, I will change. For every quiz, I will give you unlimited number of attempts. I never use in Blackboard was this option. A new attempts only allow answer for previously incorrect question. I don't know if it's useful or not useful. I don't know.
Well, very useful. Very useful. Very, very useful, yeah.
You want to click?
Absolutely.
Yeah.
At least I know what I did wrong.
It's a quiz 3 preview that we'll discuss together. What is this? How? Okay. Question 1. Constant velocity is equivalent to having acceleration equal to 0. Is true or false? Okay. It means if constant velocity, it means acceleration equal to 0. Or if acceleration equal to 0, it means constant velocity. What? No? And very useful to compare this question with the next question. What? Not. So let's see what next question. Constant acceleration is equivalent to having velocity equal to 0. Is the same or not? Okay. Okay. Already question 3. Velocity and acceleration must have the same direction. Okay. What? Question 1. What you guess? It's true, yes? No. Constant velocity, it means acceleration equal to 0. Yes, I guess it's true too. Constant acceleration is equivalent to having velocity equal to 0. It looks like the same, yes? Constant acceleration is equivalent. No, no. Constant acceleration is not the same. This is equal to 0 acceleration. This constant. Acceleration doesn't change. Is equivalent to having velocity equal to 0. No. For example, I will erase something. Fall down the constant acceleration. We call it acceleration gravity. But you see, velocity is not equal to 0. Yes? So it's not correct. Oh. Okay. Velocity and acceleration must have the same direction. Yes or no? True or false? Velocity acceleration must have the same direction. But this object, yes? What is if I release, what will be direction of acceleration? What I release, what direction of acceleration? Down, down. If I push this to left, what is direction of acceleration? Down. What direction velocity? Different. It's not. The velocity of acceleration must have the same direction. Is not correct. Okay. At time t equals 0, it means time equals 0. So we start to measure time. Know that acceleration is 0. We know that velocity is 0. None of above or below. We know that position is 0. What is your choice? So we start to do some experiment with the motion, and only start. Time equals 0. What you can say about acceleration, position, velocity? We have some information only because time equals 0. Because when we start to measure something, we don't know what we measure. But now we only start to measure. What we can say about acceleration, velocity, and position, only because time equals 0. It's no. No, we cannot say anything. So our choice is none of the above and below. Okay. Constant speed is equivalent to having acceleration equal to 0. Look like previous question. But in previous question, it was constant velocity is equivalent to now constant speed. Constant velocity equivalent to half acceleration equal to 0. We made choice true. And now, because we changed this word to speed, can we still choice true, or already time to change our mind?
Speed's like average velocity, right? Or speed is kind of like an average.
No. Speed is like length of curve of motion divided by time, the speed. So how long is your way? And we don't focus the direction.
I guess it will be
Just what in any case is speed is how fast, but without direction, any direction. For example, what's a motion by circle, circular motion? What? You can move by circle the constant speed. What? Motion by circle. You start this and do 1, 2 turns, 3 turns. Every time velocity have or this direction, or this direction, or this direction, the velocity. The velocity have direction. We can say, okay, here velocity 5 meters per second to right. This is the velocity 5 meters per second to left. This velocity 5 meters per second down. But number how fast is the same. So what acceleration? Acceleration is how fast change velocity. So what we can say is 5 meters per second to right and 5 meters per second down is the same velocity. No, velocity is different because different direction. But it's the same speed. Speed is the same, 5 meters per second. So because acceleration, the change of how fast change velocity, so this velocity, this acceleration not equal 0. There is acceleration, and we will learn acceleration in future chapter. We have this centripetal acceleration, it's direction to center. But speed is constant. So speed is constant. So constant speed is equivalent to half acceleration equal to 0 is not true, is false. Okay. Question 6. Okay, no, and maybe you have different numbers. We have to check. In my version, I have initially the object move westward at the speed of 3 meters per second. But after 1 second, it moved eastward at the speed of 4 meters per second. Do you have the same number or different? Exactly the same number, yeah? Have to be. I don't know why the same. Okay. The same number. What is magnitude of the acceleration during this section? So use the answer in meter per second squared, but don't write out the units to the answer box. Okay, what I will write this unit to the answer box. I will not write. I will need write only numbers. So no problem. How to better understand this problem? A picture. Okay. What 3 meters per second. Velocity 1 equal 3 meters per second. No. West. Okay. Right. W. Okay. Then it moves eastward. With 4 meters per second. V2 equal 4 meters per second. What is the magnitude of the average acceleration? Okay, first, what is what we have now? After 1 second. So I have time. time equal 1 second. First, what is the formula for acceleration? No, I write V1, V2, but what is the V1? Is the velocity initial. And what is the V2? Is the velocity final. The velocity initial, by tradition, I have to write V0. No, velocity final, I can write like V. So, what is acceleration? Acceleration is velocity minus velocity initial divided by t. Okay, we remember formula. We know this formula, acceleration. So, but how I will use in this formula W and E? Because we have to write this number. No, good idea. I do choice. What is the positive direction? For example, east positive direction. So west, east and west, east and west. So west, if I want to use the same E, so I have to write this minus. Yeah. So because now it's the same direction, I can use only numbers. So acceleration is final 4 meters per second minus initial. Initial is a minus 3 meters per second divided by 1 second. So what result? 4 minus 3 help me. What result? 7. And divide by 1. So 7. Okay. What I have to write here after 7?
Meters per second squared.
Meter per second squared. Meter per second squared. Okay. Now I focus you. What is the magnitude? Can I write 7 to answer? Yes, I can write 7. Because what's my magnitude? Positive number. If I will have minus 7, in any case, I have to write 7. The acceleration can be positive, negative, but magnitude can be only positive. So I can write 7. 7. Okay. No. What? You saw my example. It's in problem 6. Now what? Try to do problem 7, just without my help. No, question is the same. This what is acceleration? But now the object moves westward at the speed of 3 meters per second. So it's W. But after 1 second, it moves again westward at speed 4 meters per second. What's the magnitude of the acceleration during this second? Okay, and give me answer. Now, without my help, write by yourself. It's easy problem. Idea is the same. Only you have to focus on new text. Deal with new text. What is the difference between text? What? Compare with previous problem. Focus to this.
More 1 meter per second squared.
Meter per second squared. 1 meter per second squared. Yeah, okay. You understand, children. I hope you understand. Okay. Let's go to next. Now, situation 8. Okay, again, the problem looks like the previous problem. Initially, the object moved westward at the speed of 3 meters per second, but after 1 second, moved northward, the speed of 4 meters per second. What's the magnitude of the acceleration during this second? Okay, what? See, what's the difference? I will change the answer. Try and think by yourself first, and then if you answer. So if I want to write like scheme, what happens? So we have two velocities. This is a map, for example, north, south, east, west, if I remember correctly, direction. Okay, so what we have? 3 meters per second. What is it? This is a velocity initial. Velocity initial, 3 meters per second, and I show direction. But 10 northward, 4 meters per second. Okay, north, okay. I got 3. So this is a 3, 1, 2, 3. Velocity initial. Ascend north, 4. 1, 2, 3, 4. This is a velocity. So this velocity. So we have to find acceleration is a v minus velocity initial by time. What you know about how we can do this? But you already have some lecture about that. So what's the result? Any your attempt, student? What answer?
5% correct. I think they should go 1 because 4 is positive.
Yeah. How to show this? No algebra-based math. What does it mean? Vector. What does it mean? Vector minus vector. And finally, question is what is the magnitude? What's the magnitude? So what we have vectors. No, first velocity initial. Velocity initial is a vector. It's better to show like this. It's a vector. It means have direction. How we can show vector using numbers? You have to say what is the for this vector v0. What is the component x? No, what component y? What component z? But because now we work with not x, y, z, we work with the component. No, let we will call this direction to east is the x, this direction to y, this direction to north. So what we can say about for initial velocity? What velocity initial? What is the x component? X component is this direction. You see, they have direction to left. This means it's a negative because positive direction x is this direction. So 3 is minus 3 meter per second. What is the Vy? What the component for initial velocity to this direction, to this direction? 0. 0. Okay, now what is the final velocity, v. Again, we have x, and again, we have y. What you can say about x? This arrow don't have direction to right and to left. So x is a 0. What is to direction to y? 4. 4 meter per second. Do you understand here? Yes? What? Because it's a y. What does it mean? Velocity minus velocity initial. Again, we have these two components, and we have to do the same to each component. It's component x. So Vx 0 minus component x for velocity initial. This 0 minus 3. So it will be plus 3 meter per second. From this minus this. From component x minus component x. We have component x of this subtraction. The same for y. This minus this. The component y, final velocity, minus component y, initial velocity. 4 minus 0. Because it's a 4 meter per second. And now what we have? We have vector. What result vector? One component equal 3, 1, 2, 3. Another component equal 4. Okay, I will put 1, 2, 3 x component and y component 1, 2, 3, 4. What is magnitude? First, we have to draw this vector. This is a vector. This is a 3. This is a 4. This is 3. This is 4. And what is magnitude? How long is this? What we use to find how long? Pythagorean theorem, because this is a 90 degree. So this length, we call this magnitude equal root squared from 4 squared plus 3 squared. Pythagorean theorem. 4 squared 16, 3 squared 9, 16 plus 9 is 25. Square from 25, 5. So we have 5. So our answer is this magnitude equal 5 meter per second squared. Do you understand, student? Okay, so 5. Oh, what? I forgot this. No, that's what this 5 and previous problem. Answer was 1, yeah? If I remember correctly. 1. What more? That's more of an answer. 7 of 8. Three questions set. This I have answer, this I have answer, this, this. Okay, I will try to run. Submit quiz. What is my grade? Oh, my grade is A. No questions about this. Yeah?
I have a question about quiz 2.
Quiz 2. Okay, let's go to quiz 2.
The last three in particular.
Okay, 10-1, 10-2. Well, which questions? All of them. I can plan all of them, but
I have trouble with 6, 7, and 8.
okay, 6. Select correct equation for motion with constant acceleration. Because first we have to focus to our textbooks and we have to check what kind of formula you see in our textbooks. And if I remember correctly, in your textbooks, we have this. Oh. First, we have for motion the constant A. We have formula V equal velocity initial plus acceleration times t, the for one-dimensional motion. Yeah, acceleration times V equal. So, and now we have to compare what we have. No, and what student? But if it, you saw some formula, of course you remember the formula in some view what you see in textbooks. But of course, because you know algebra, you know math, if you will write, for example, V equal TA plus velocity initials will be the same for, it will be the correct formula. This correct formula, of course, correct formula. What? So mathematically the same. If for example, I will write V minus velocity initial minus AT equals 0, it will be correct formula. Again, correct formula. So what's using, but if we can transform this formula using algebra transformation, it doesn't change equivalency left and right. So it's correct formula. If we will change that, we will change equivalency. That's not correct formula. What? Let me start. What? Okay. And increase. What we see? What velocity initial equals V plus AT is a correct formula. No, not correct. V equal velocity initial plus AX is a correct formula. No. Velocity equal velocity initial plus AT.
Yes.
Oh, this look like correct. Yes. Okay. Velocity equal velocity initial minus AT. Doesn't look like correct. Yes, because minus. Okay, this.
Yes.
Yes, 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 yes. What? No, this. We know A is acceleration. What is B? We don't know. So it's not correct formula, yeah? Okay. AT equal V0 minus V. Or is it correct or not? No, it's not correct. Yes? Not correct. VT is this. We don't know what's the V. Yeah? What? AT equal V minus V0 is correct? So we move. What? We start with this, but we move V0 to left. When we move to left, we have to change sign. So V minus V0 equals AT, or AT equals V minus V0. So it's a correct formula. Okay, so what? Question 6. Select correct equation for motion with constant acceleration. Again, first we have to focus how we remember this formula. Correct equation for motion with constant acceleration. But now we have x. No, what? No, I see already formula number 1. First formula x equals x initial plus velocity initial t plus acceleration time squared over 2. The correct formula. Hmm? Why no?
I have it written down somewhere, and it wasn't
What? What's first and second? Is the difference between first and second? Only this 80 squared divided by 2, and this 1/2. This VT squared. What? Second not correct, because V. First correct, but this correct formula. my guess. Okay. No. For this formula, what is different? On the left, not x, x0, but on the right, x minus velocity initial t minus 1/2 at squared. My guess is correct according to algebra. Yeah. Okay. Now x equals, no, is some strange. Velocity initial is not correct. X equals x initial plus, no, this b. I don't know what, I know a acceleration, but b, I don't know what is the b. Okay. X, no, x0 on the left. No, this, I see this one. On the left have to be x, on the right x0 and all classes. So this is not correct. Okay, x equals 0, what? Vt have to be velocity initial. There is a big difference. Velocity or velocity initial is not correct. X equals x initial plus velocity initial t plus 1/2 at squared. Oh, it looks like correct again. I don't see mistakes here. X initial equals velocity initial t plus 1/2 at squared. Look like again correct. Okay. What? So, no, of course, we can do some occasional mistake, but we focus to which formula is now what.
How many of those are right? There was 4 or 3. There 4 or 3 that were right.
What form? 3?
Question number 6.
Question.
No, like how many? Yeah, how many did you click?
How many times?
Yeah, you clicked 3, right? 3. Okay.
1, 2, and last 3. My choice. X initial, velocity initial t, 1/2 at squared. X. Okay. No, and what? No, this really, no, to remember, enough to remember the next form. X equals x initial plus velocity initial t plus acceleration times squared over 2. I remember like this. Then we will change some, if it will change something, what? We have to check. During the changing, is the algebra left part equal right part or not? Okay. No, and what last formula? Question is this last or not? Yes, last. Okay, so this we remember in form velocity squared equal velocity initial plus 2 acceleration x minus x initial. What we have to remember like this? On the first position, exactly we see this correct formula. We have to remember this. Okay, then we have to compare with another. What is different? This is a change indexes, yes? But not correct. This is correct, this is not correct. Okay, this, for some reason, is T, not A. No, student, no, it is not correct. I confused. I confused, it's not correct. What's correct? Perfect. I have to find correct formula. No, maybe correct. Maybe, no, it's correct. Because 2AD. No, look like correct. I confuse because sometimes we remember like this is a D, it's 2AD, but X minus X0 is the displacement too, the displacement. Okay, this is correct. So this is not correct. This is not correct because T. This is not correct because T, B. This is not correct because minus. What? This is not correct because plus here. This. Okay, let me check this. This what? Each. So we have b squared equals velocity initial squared plus 2a x minus x0. And now we move this to a x minus x0 to right. So this, my guess is again correct. What? Answer three last. Okay, student. So, question. Question 5? Quiz 5. Or question 5. Question 5. Okay, 5. Question 5. No. So this correct formula we have to what it is on the velocity where we have v0, v and v average. No, and what's important here we have to read select correct equation for motion is a constant acceleration. And for constant acceleration, we remember next formula. This was relationship between velocity average, velocity average. What this means average equal, okay, velocity initial plus velocity final divided by 2. It's like average of two numbers. So it's correct only if a equal constant. Is equal to mean acceleration doesn't change. So this formula is correct. So where we see 5. What? This we don't have sign average. This right part look like my part, but this not average. Okay, this was the average equal v plus the initial divided by 2. This is correct. Okay, no, this divided by 3, not correct. This no any division, not correct. Okay, this sign minus, not correct. This velocity initial plus v divided by 2 velocity average, it looks like again correct, yeah? Looks like again correct, the same. By 4. Okay, so good. Yeah. No case student. So now what you see problems. How many problems? It's quiz. I call this quiz. So more you homework. And now we will start new chapter and new topic. Yes. Previous chapter about motion. We described motion. No, and we use two motions. Motion with a constant velocity or constant speed and motion with a constant acceleration. There is some another motion, but we don't focus on another motion. Some circular motion, some oscillational motion, and so on. But what now next chapter we will learn how we explain what is the source or reason of motion. What is the reason of motion? And what? So name of chapter, Newton's law. Newton. And we have 3 law, 1, 2, 3. Better to remember this was the 3 Newton law using formula. In second Newton law, we have to remember next formula. It looks like F equal ma. So, and now what we learn from this formula? No, F is a force. So there is in the universe forces. And what make these forces? Forces make acceleration. What is that for us? I push it means I do force. I do force. There is a different forces. For example, gravity force. Earth push me down. We call this gravity force. If I will beat, I push this wall with some force. No, and if we have only one force acting to object, so this force produce acceleration, just change in velocity. So what does it mean? Because we have gravity force acting down, but this reason this just now it don't move. Why it don't move? Because there is two forces acting to this eraser. One force acting down, the gravity force, another force, I made this force. I push up, but this don't move. But if I release, only one force acting to this. And what made this force? Made acceleration. Because acceleration is also go down. Yeah. So as you know, this is a force, F because F, this acceleration because S, what's the M? M is a mass. So, no, if I will rewrite this formula, if I know force and I know mass, how acceleration depends on this. If I will use correct algebra transformation, I can rewrite acceleration equal force divided by mass. And what we see, if mass is a greater, because mass located on this formula, the bottom, if mass is greater, acceleration is less, yes? So this mass show us how fast with what acceleration, how fast will be like how a big will be acceleration with the same force. And what is if mass is greater, then acceleration is less. Mass. How we feel mass? If we use some force, we try to push something. If you see your small force already have big velocity, so mass is low. I try to push, but don't move. It means mass is a big mass. Okay, so main formula. Some conclusion from this formula. What? If acceleration equals 0, it means force equals 0. Yes? Acceleration equals 0, force equals 0. Okay. What does mean acceleration equals 0? Is it mean constant velocity? Constant velocity, it means force equals 0. But no, what I will try to check. What I use this on the table. And initially it's move to left, and then stop. So we have this acceleration. Yes, of course, because we see that there is change of velocity. Yes, of course. So why it's acceleration not 0, but why where the force is it stops? What kind of force? Okay, there is a many force. The friction force. Yeah. Okay, so no, in any case, what? How we remember? Newton law, 1, 2, 3. Second law, we have to remember this formula. F equal ma. Okay. What is number one? No, there is the old explanation of Newton law number one and new explanation. In old explanation, what we can explain this: if f doesn't change, constant, then what? Acceleration equals 0. If force not constant. If force equals 0, then acceleration equals 0, not constant. And what does acceleration equals 0? It means velocity is constant. Velocity doesn't change. But you see, we have the same information in this formula. So if force equals 0, then acceleration equals 0. It means velocity is a constant. But how we understand now Newton law number one? Because we have already the formula, we understand like this. To measure acceleration, we have to use some system related to what we have to measure motion. Where located this system? If this system located, for example, on the car, and car can move, car can turn, so this formula will be not correct. So only this formula correct, this formula in special system of measurement. Are we located this system? No, if, for example, if we will draw this X, Y, and Z axis on the Earth, can we use this for this formula? For motion cars and for motion of some plane, we can use formula, but already for motion, for rockets, we cannot use this formula. So if to describe motion of rockets, well, we can to draw this. We can focus to stars. Stars look like they don't move. So star is a best like place to move, to draw axis. What is we cannot really draw axis, but we think that this axis have to be not moving relative to stars. So this main idea, there is some special system of coordinates relative to which this formula is correct. Not for all systems correct. For example, it's located on the bus, located on the car, located on the something with the moving and change direction. So this is not correct. Second law is correct. So we have first law. No, really, we can understand like this. For some special system of measurement of motion, this formula is correct. Second law is correct. Not for all. Okay, so 1, 2, what is the 3? Very simple, like sentence by number 3. Action equals or opposite to reaction. How can I understand action and reaction? It's like force. So any force don't exist alone. Every time we have two objects. And force every time exists between two objects. What one object knows another object. You understand what is this? Yes. If this object action to north with some force is an action. At the same time, this north acting to this object with the same force but opposite direction. Action equal reaction. So if you see one force, so you know there is an opposite force. No, let's try to find some example. What you know about gravity attraction. So the Earth push me down. Let's call this action. What is the reaction?
Push up. Push yourself up.
I push Earth up.
Or you push you up.
No. Okay, what this is a Earth, yes? This is a me. And Earth push me down. And you see this. If I will jump, you see I go down, yes? But in the same time, I push Earth up. Only you don't see. Why? Because Earth have very, very big mass. If Earth push me, you see this. How at the same time Earth go up, you don't see. Because Earth have very big mass, it's not visible. Yeah. Okay, so what action, main idea. Every force don't exist alone. For every force, we have opposite force, because every force produce two objects. One object, the first object acting to second object is an action, but at the same time, second object acting to first object is a reaction. And forces equal by magnitude, but opposite by direction. Yeah? Okay. No. Really, when I will give you problems about this Newton law, we will work with this formula. Yeah? Okay, then we will try to do some example of problems. No, simple. No, at the same time, we will know what are units of measurement. So you already know acceleration, meter per second squared. So no, that what is it? You need to measure force and you need to measure mass. Unit of measurement. Maybe you know mass. I don't know, maybe from high school, maybe from chemistry. To measure mass. What do you need to know to measure mass? Unit of measurement. Who know? Any unit of measurement. Measure mass.
Grams, kilograms.
Kilograms. This is 10 kilograms. 10 kilograms. Kilogram is the basic unit. Of course, we can use grams. We have some classes in chemistry to measure how big is some object. We can use what? It can be imbalance no, and we can measure that in grams, 20 grams, 30 grams, yes. But this is the math, But there is kilograms. Force. In science, basically, need to measure force is a Newton. Kilogram kg is force, the tradition by rules. You need to measure force in Newton and you enter to be capital because Newton is the name of the scientist. Yeah. And acceleration, not measured in meter per second squared. Now what? Let we know some force 10 Newton acting to the mass 2 kilograms. What is the acceleration to produce this force?
Meters per second squared.
Okay, I have this formula. Air equals ma. But this one I cannot calculate. Yes, but I do. Also, calculation, right? A equal what? Air over F. Okay, F is a 10, 5 kilogram. So what is F 10 divided by 5? Is a 2. Use correct mass times Newton over kilogram. But we have to know Newton over kilogram is equivalent to meter per second square. So right, 2 meter per second square. Because we know it's Newton equivalent to kilogram times meter per second square. Okay. What happens if we have not one force, we have many, but we have to add this force. Okay, next problem. Now I will have two forces. Okay, force 1 equal 3 newtons and acting to, okay, to right. I by error show direction. Let F2 equal 4 newton and acting to left. I show like this, acting to left. Okay. And we know mass of object, F1 and F2 acting to this mass, equal, what? 1 kilogram. Question, what is the acceleration of this object? No, first I have to think. No, I know formula. Acceleration equal force over mass. But I have to make some decision. How I will write? To right, to left? No, your guess. How can you use the formula right and left?
Make one of them negative?
Yeah. I made decision. Okay, to right will be positive. So it means to left, we can write like to the same, to right, but already negative. So what is the total force? 3 Newton to right plus minus 4 Newton. So we have result is a minus 1 Newton. Yes, minus 1 Newton. According to our decisions, that to right is a positive, we have minus 1 Newton, or we can say 1 Newton to left, because left is a negative. So what's acceleration? Minus 1 Newton divided by 1 kilogram. So what we have? We have minus 1 meter per second squared. As you already know, Newton over kilogram is a meter per second squared. Minus. Is if question is what's acceleration, you have to write minus 1 meter per second squared. But be careful. If question is what is the magnitude of acceleration? What will you answer?
1 meter per second squared?
1 meter per second. Yes, a magnitude means positive number.
What if you made the 3 negative? Wouldn't it be positive anyway?
No, it maybe positive, maybe negative. Doesn't matter. Okay, you want to change this to 3 Newton. Okay, minus 3 Newton, minus 4 Newton. What result? Minus 7 Newton.
Well, no, I meant like if you kept like the 4 positive and made the 3 negative.
4 positive, 3 negative. It will be 1.
It would be positive 1, not negative.
Positive, yes.
Would it still be correct?
Hmm?
Would it still be correct?
Yeah. Okay, I will change this. Okay, the data. Okay. 3 Newton up, 4 Newton, no, right. Again, what acceleration? And you already maybe have guessed because you remember we have already something like this. Yes. 5. Yes, because 3 Newton up, 4 Newton left. You know it's a vector. We have one component have 3, another 4. Magnitude equal 5. Yeah. So for question, what is the magnitude of acceleration? But look, there is some details. We have to focus. What is the question? What's the question? If question, what is the magnitude? So answer will be 5. But exactly what's acceleration? Now vector. Because you have two components. Component x, a component y. So acceleration will have again two components. So we have to say what's acceleration to component x, what's acceleration to component y. For component x, we have to use 4 Newton divided by 1 second. No, 1 kilogram. So we have 4 meter per second squared. And for direction y, we have 3 Newton divided by 1 kilogram. What we have? We have 3 meter per second squared. So if question is a what acceleration, you have to show like this. Yes, there's two answers, like no, two numbers, component x, component y. If question is a what is the magnitude, okay, you have one answer is a 4 squared plus 3 squared root squared. Yeah. Okay. Newton law. And some different version. Okay, no, now I will try to give you. Okay. Let me know some object. Usually other and no mass. 1 kilogram. And we know force acting to the solvent. That's what we call before. Our problem is about one-dimensional motion. So the force acting in that direction, force equal 3 newtons. Mass. Already know how mass and force is applied application. I remember I said initially at the rest, velocity initially equal to 0. So question, what will be velocity? Velocity equation. When after time, after beginning of this force, after time, 2 seconds. So now you know mass, you know velocity. Velocity initially equal to 0. You know mass, you know force, you know time. Question, what will be velocity? 2 seconds. So now you have to apply not only Newton law, because Newton law don't give you time, yes, so don't give you velocity, yes. Newton law gives you only acceleration. So we have to use what? Moment formula. From previous chapter, we have the relationship between acceleration and velocity. Okay, students, first try to do the problem without my help. One minute. Zero the expiration. And 4 is also right? 4 equals 3 newtons. In this moment, velocity equals 0. This was force up into this. We have acceleration and reach this point. At this point, time is 0 equals 0. And this is time equals 2 seconds. So question, what is the velocity here? Try to do without my help. Later, give me answer. Okay, we get one answer. Velocity final. Velocity final equals 6.
Also,
Yes. What's the our solution? Maybe in some another, no? Okay, 6. Let me check. What? I teach you how to find solution of problem. If you have first you have text. After text, you write something like this. You write what you know, using from the symbol, number. After this is in what kind of equation will be? Because you have force, okay, maybe build one equation, force equals A is useful. Because you have the formula, you can calculate the velocity equal to force over here. Yes, but if we don't have a great answer, so we have to have something. Another. What was it in relation to acceleration equal velocity minus velocity initial divided by time. So think about this formula. And because we have to find velocity, velocity equals velocity initial plus acceleration times. So we know velocity initial, yes, we know time, 2 seconds. So acceleration we can find using this formula. So final formula, last formula, what we will use, velocity equal, velocity initial, no? 0. I will not write it. Plus, so plus, acceleration, take F over M. F over M times T. This is a equation for the velocity. In data, you know F, yes, you know F, you know M, you know M, you know T, you know T. So this is a very solution, yes. And if you apply the formula like this, I think already 90% of time. Yes. But it's already solution. Next step, okay. Okay. How to do that? Yeah. They will give you exam on the paper. You have to go to solution according to rules. What kind of rules? When you write something, you have to write not only number, but to write unit measure. You have to show operation. The number, you have to do operation, unit measure. So F 3 Newton divided by Newton by mass. What's the mass? 1 kilogram times 2 seconds. 2 seconds. Okay. Duration with the numbers. 3 times 2 divided by 1. Help me. What answer? 6. Duration with the units. Newton over kilogram and times second. Is that good? Not good. How to find good? We already know. Newton equivalent. You have to write 6 and you can write kilogram meter over second square. Remember, Newton equivalent kilogram. Oscillation times mass. So it's a big cushion in Newton. Okay, now times second and divide by kilogram. And what you see? Kilogram cancelled. And second this is a cancelled. So 1 second cancel. What is it finally? You will have finally meter per second. During well, is a meter per second. If you find calculate velocity, but you have 6 meters. 6 correct number, but it's not that. Not that. Yeah. Units of measurements. And sometimes we check solution by the equation. Example, what is the force? You have 5 seconds. No, this is not correct now. Okay, no, some simple questions about acceleration. Okay. But let I know in some object, I draw this object like circle. We have 5 kilogram mass, acting forces to right. 1 Newton up, 1 Newton left, 1 Newton down, 1 Newton. So it's total 4 forces. What's the acceleration of this object? Zero. Because total force, 1 up, 1 right, 1 left, 1 down, 0. And because total force equals 0, so acceleration equals 0. Yeah? Okay. No? A little bit more or a more difficult problem. Let we know objects have mass 1 kilogram. And initial this object on the rest. There's no motion. Rest. And some force acting to this object. And what we found? After 1 second, this object changed position. And now position of this object 5 meters. That's the initial position over x equal 5 meters, x initial equals 0. Question. What force acting to this object? So again, I will repeat given data. Object initially on the rest, so don't move. And we know mass of this object. And we know and location x equals 0. And we know because of some force acting to this object start to move, and after 1 second and reach position x equals 5 meters. Question, what is the force? Okay, first try to find solution without my help.
Five minutes.
5 Newton. I don't believe it's correct. 5 Newton. Okay, we have one solution. Force equal 5 Newton. Okay, but I will check your answer. What if force equal 5 Newton? Yes. So mass is 1 kilogram. What's acceleration? Acceleration equal 5. This acceleration equal force over mass. Force 5 Newton, mass 1 kilogram. So we have 5 over 1, 5 meter per second squared. There's no acceleration. Having no acceleration, we can use formula for x. X equal x0 plus velocity initial times v, velocity initial times t, plus acceleration times squared over 2. We know this formula from previous chapter. X initial 0, velocity initial as the rest 0. So we have only this. This x have to be equal what? Because we know time equal 1 second. Acceleration equal 5 meters per second. 5 meters per second squared times 1 second squared. 1 second squared is a 1 second squared. Divide by 2. So what result is a 2.5 meters. We have 5 meters. So your answer, your guess for equal 5 Newton is not correct. Because with this force, position will be not 5 meters, it will be 2.5 meters because of this formula. This is the main formula, what we can use. Can you? Let me check now. So I will write okay. If a problem, you have to write given data. If you have already this data, I will rewrite the data. So what we know? We know x initial, 0 meters, we know velocity initial equal 0 meters per second. What we know more? We know mass, 1 kilogram. We know what we know more. We know velocity. We know x final. X final is 5 meters. That's all. And we know time. Yes. Time 1 second. Time 1 second. What we have to find? We have to find force. Okay, no formulas. We have to write formula. Your formula F equals MA. to M. So we know M 1 kilogram, but we don't know it. So we have to find something, some equation, we can relate to acceleration and data was no. And so they don't know what they want to use. They want to use for x equal x0 plus velocity equal 3 plus acceleration times the whole. Because x0 equals 0, v0 equals 0, don't take the solution. X equals a t squared over. So from this, can we find a from this? Yes. What is the a? So a, we will use algebra geometry. So to keep a alone, I have to divide left and right part by t squared and multiply times for x divided by t squared times 2. So now I can use a in this formula. The final formula F equals mass times acceleration. Acceleration I can write like 2x divided by t squared. So this is my final expression. In the solution, we have to find F here, F on the left. What you know? We know M, yes, we know M, we know X. Now we have to do something. Okay, no, I don't have space, I will use space. So I have to write F equals mass 1 kilogram times 2 times X 5 meters and 5 meters. Like that, 1 second. Good. So those numbers, 2 times 5 divided by 1. 10. Yes? Is enough? No, it's not enough. You have to show me what is the units. Kilogram times meter over second square. I remember this combination is exactly Newton. So, okay. Good. Okay, what more today? Okay, now for 5 seconds, 5 minutes. Very short questions. I will repeat some. Okay. Always start here. Can we say something about average force happening to the soul? I didn't give you definition what is average force, but your guess, and you can guess what you can say about average force. Start, open over. You know formula. F equal MA. There is no average force. But maybe you can get you can guess. If F equal MA, what you can write? F average equal if M doesn't change. So try to continue. Maybe just can we know more? Can we say something my question. Can you say something about everything or not? Okay. You don't, I don't any guess? Let's start here and finish the same way. So now say something about it. Okay, another question. If you know about all, start, but now I don't know where it starts, but then I start with the velocity. 5 meters per second to right. And move. And I don't know where, but there was initially go again 5 meters per second. Right. Can I say something about average force cut? And finish the same reward. What you can say about average acceleration? We might go forward. Average acceleration equals velocity minus velocity initial divided by time. Average acceleration. If velocity equals velocity final the same, but average acceleration equals 0. So it denotes because if average acceleration equals 0, average force equals 0 too. If we know velocity, it doesn't change. So we can say, oh, average force actually equals 0. Please, we don't know anything about velocity, no position. Position only, you know, position initial, position final, the same position, but it doesn't mean velocity is the same. So this, we cannot say anything about force, but this we can say about it. We don't change of velocity, because you know, change of position is not enough to say about force. Because I don't know about velocity. Okay. Any questions, students? Okay, what you have to do at home? Whole work. Every time I will not repeat, but you have to every time you have to read your chapter, your textbook. Yes, now a chapter you don't work. And you will find in if you are good, go. Yes, but I will not check. I will after you can play. Yes. Or again, if somebody want to take extra credit, now somebody will play me problem from any form of program the blackboard and give you extra credit. Yes. Yeah, now I have 40 hours. Yeah. The question I will give right? Yeah. Yeah. Same. Right. Okay. I forget the sentence. Okay, I forget it. All of here. Zeros and velocity formula. Yeah. Yeah. But then, acceleration, velocity, equal time. So we can say acceleration minus, yes, yes. But if you know position, you do position minus. Cannot do it.
So I'm memorizing formulas for sure. Because I made a mistake there. I used the average acceleration formula instead of the acceleration formula. I did it wrong. Because it's I'm supposed to use the other one, the average acceleration. So
Okay, no problem. It's good that you try to find some. Look,
yeah, of course.
mistake is a fantastic mistake. I have a mistake.
I didn't think about it. That's why I just did it. I have a question, Professor. Do you do labs? Like, do you have a lab class for that?
Sometimes, but not this semester. If you have a question about labs, I cannot help you.
Oh, gotcha. No problem.
No. Any question, lab question, on this or some, any question, some another class, I don't know.
Fair enough. All right. So, wonderful.
Bye-bye.